ratio, it's important to remember that order matters, so you have to pay close attention to the question. Here I can see that I'm comparing cookies to students. That means that every time I write my ratio, the number of cookies is going to come first. So in this problem, I have 10 cookies, so the 10 gets written first. I can look back and see that I have 5 students, so the 5 is my second number, 10 to 5. Now, ratio notation is how we write that ratio. And this ratio can be written 3 different ways. The first way is using the words 2, 10 to 5. The second way is to write it as a fraction, 10 over 5. The numerator is always going to be that first number, and the denominator is always going to be our second quantity. The third way I could write it is using what we call a colon. A colon are those 2 little dots that you see after words sometimes. Now, if I'm using a colon, that order is still going to stay the same. So my 10 is going to come first, 2, 5. And what this is telling me is that for every 10 cookies, there are 5 students. A ratio is simply a comparison of 2 quantities. So when I look at my ratio here, I can see that I have 10 cookies for every 5 students. I can tell by this ratio that I have more cookies than I have students. So if I were to split those cookies evenly, I can expect that each student will get more than 1 cookie. When you see words like for each, per, or for every, you know you're going to be dealing with ratios. Remember that order matters. So if they ask for the ratio of cookies to students and I give them 5 to 10, I've put in the number of students first, which is not what they asked for. That would be wrong. Next, I'm going to go over equivalent ratios. Now, equivalent ratios are simply ratios that are equal to one another. Remember, when you see that word equal, it always means the same. In other words, any equivalent ratio I have, the value, the total value of those numbers is always going to be the same. Let's take a look at some examples. So if I have 10 cookies for every 5 students, I would write my ratio starting with the number of cookies, because remember, order matters. So I have 10 cookies, and I can write this ratio as a fraction. So I'm going to write over 5 to show that we have 10 cookies for every 5 students. Now, remember that this is a fraction, and so all mathematical rules that apply to fractions can apply to this value as well. So if I multiply the top number and the bottom number by the same number, what I'm really doing is multiplying this fraction by 1 whole. And if I multiply anything times 1, you get the same amount. So, by multiplying both sides by the same number, I'm keeping the total value the same, but coming up with a new fraction that can be my equivalent ratio. So 10 times 2 gives me 20, and 5 times 2 gives me 10. Therefore, 20 to 10 is an equivalent ratio to 10 to 5. I would read this as having 20 cookies for every 10 students. I can double check to make sure that my fractions are equivalent by dividing the numerator by the denominator for both of my ratios. If they're the same, I should get the same answer for each. So let's double check. 10 over 5 means I would divide 10 divided by 5, which gives me a quotient of 2. 20 over 10 should give me the same quotient if they're equivalent. Let's check it out. 20 divided by 10 equals 2. And yep, those are the same. So they are equivalent ratios. Just a quick reminder, if you're wondering why I decided to divide the top number by the bottom number, take a look again at how we write fractions. And remember that this line in the middle here means to divide. Now let's say instead of a larger equivalent ratio, I wanted a smaller equivalent ratio. It's really the same process as long as you remember that multiplication and division can be thought of like opposites. So, if I start with 10 to 5 and I multiply to get a larger ratio, then I can do the same thing with division to get a smaller one. I know that I can divide 10 by 5 and I can also divide 5 by 5. We're still dividing by one whole, and this time 10 divided by 5 gives me 2, and 5 divided by 5 gives me 1. So 2 to 1 is an equivalent ratio to 10 to 5. And since it never hurts to check your answer, let's check our answer. 2 divided by 1 equals 2. Once again, it's the same. Finding equivalent ratios gives us numbers that are easier to work with. Whenever we're comparing ratios, it can always help to use a common denominator. For example, if you have two teachers who bring in cookies, and the first teacher brings in 10 cookies for 5 students, and the second teacher brings in 75 cookies for 25 students, you might be wondering which teacher brings in more cookies per student. Well, in order to compare these numbers, I first have to find a common denominator. So if I just compare 10 and 75, I'm only comparing the cookies and I'm not taking into account the number of students. 75 cookies is way more than 10 cookies, but 25 students is also way more than 5 students. So in order to work with easier numbers, I'm going to come up with a common denominator. It's difficult to compare these ratios as is because they're comparing different numbers of cookies to different numbers of students. So while 75 is higher than 10, 25 is also higher than 5. It helps to find a common denominator that you can use to compare both the ratios. So I'm going to use my equivalent ratio strategy to find a common denominator between my two ratios. I know right away that 25 is a multiple of 5, so I'm going to go ahead and divide this ratio by 5 over 5 to come up with an equivalent ratio. 75 divided by 5 gives me 15. 25 divided by 5 gives me 5. So 15 to 5 is an equivalent ratio to 75 to 25. Now if I compare the two, I can see that the second teacher brings in more cookies per student because for 5 students, she has 15 cookies to share, whereas the first teacher only has 10. Once again, it never hurts to check your answer. 15 divided by 5 gives me an answer of 3. 75 divided by 25 also gives me a quotient of 3. Therefore, they are equivalent. Another way to find equivalent ratios is to use a ratio table. If I have 10 cookies for every 5 students, I can put that information into a table by putting a 10 for cookies and a 5 for students. The easiest way to complete this table is to use repeated addition. If I have 10 cookies for 5 students, then I can add 10 and get 20 cookies and add the 5 for 10 students. This is called repeated addition because you repeat that pattern all the way throughout the table. So 20 plus 10 will give me 30 cookies, and 10 students plus 5 more gives me 15 cookies. Now I have 3 equivalent ratios, 10 to 5, 20 to 10, and 30 to 15. Once again, I can check to see if those ratios are equivalent by dividing the top number by the bottom number. 10 divided by 5 gives me 2. 30 divided by 15 also gives me 2. Therefore, 10 to 5 and 30 to 15 are equivalent. You can also use multiplication and division to complete a ratio table. Let's say I wanted to know how many cookies I would need if I had 30 students. Well, I know that for 15 students, I need 30 cookies. 15 times 2 gives me 30. So, in order to keep this relationship the same, I have to do the same thing to my top number that I did to my bottom number. 30 times 2 gives me 60. Therefore, if I have 30 students, I'll have 60 cookies. I can go backwards as well. If I decide to divide 10 by 2, I get 5. And if I divide 5 by 2, I get 2.5. You may notice another pattern when you look at a ratio table. So if I look at my 5 here and my 10 here, I know that 5 times 2 gives me 10. 10 times 2 gives me 20. 30 times 2 gives me 60. So if I have a number like 50 on the bottom, I know I can find the top number by multiplying by 2. 50 times 2 gives me 100. So for 50 students, I would have 100 cookies. Now let's say I know the number of cookies, 80 cookies, and I want to know how many students should get those 80 cookies. I know that in order to find the number of cookies, I multiply by 2. Well, division is the reverse of multiplication. So if I divide my 80 by 2, that will give me my number of students. 80 divided by 2 gives me 40 students. Now I'm going ahead and check once again. 80 divided by 40. If this is an equivalent ratio, my answer should be the same as my original ratio. And it is. Hooray!